Remember these 5 equations that I showed you on the first day of class? We're making our way through Maxwell's equations of electromagnetism. We've already discussed the electric force and the magnetic force, Gauss's law for electric fields and Gauss's law for magnetic fields. And now we finally get to the 4th equation on this list of equations for electromagnetism. So the 4th one is Faraday's law of induction, and that's what we're going to look at today. What we'll do is break this equation down and make sense of every part of it, and then we'll talk about applications of Faraday's law of induction. I'd like to start with a little history. It was around 1820 that Ørsted accidentally discovered that a current produces a magnetic field. He was actually working with circuits and he had a compass nearby, and when he ran a current through the circuit he noticed that the compass needle moved. About a decade later, Faraday got curious about this and wondered if it worked in the opposite direction. What he wondered was, well, if a current can produce a magnetic field, does a magnetic field produce a current? And so he did some experiments, and what he found was it wasn't exactly that. What he found was that only a changing magnetic field would produce a current. In Faraday's experiments, what he looked at was magnetic flux. Now, we've calculated flux before for electric fields. Now we're just going to do it with magnetic fields. And what he found was that a magnetic flux, if that changed, then there was a current that could be induced. So the area that we're going to talk about is the area of a loop of wire, and we're going to send a magnetic field through that loop of wire. And if that magnetic field or the area, if the flux changes, then we're going to see that there is a induced current. Based on what you know about flux, I want you to answer a few questions about changing flux.